Hi friends, welcome back. Today we're talking about graphing polynomials, the x-intercepts, when you have your x-intercepts. Okay, so x-intercepts are also called roots or zeros. Zeros. I don't know if it has an E in there. Ooh. Okay, or you may even just hear them referred to as solutions or x's, right? Okay, so what this means is when we're finding our x-intercept, we set y equal to 0. When we're finding our y-intercept, as we learned in a previous lesson, you set your x equal to 0. So to find your x-intercepts, set y equal to 0. Make sure to write that note down. This is really helpful. Okay, so let's take a look at this one. We are going to graph this, f of x equals this. Now, you are not, this is x to the third. I know you are fantastic at factoring when you have quadratics, x to the second. You have not yet learned how to factor x to the third, so I've gone ahead and put it into factored form for you here. Okay, so what we're gonna do is take a look at this guy right here. So if we've got y equals x to the third minus 13x plus 12. Okay, so there is our solution right there. Also on Desmos, if you ever hit this home button over here, it takes you right back to the origin. It looks nice and great. Okay, so looking at this, we have that it crosses our x-axis right here at -4, at +1, and at 3. So our x-intercepts occur along -4, 0, 1, 0, and 3, 0. So if you take a look at our factored form here, you see that this guy, it's just like when we were dealing with quadratics. We use our zero product property and set this equal to 0, and we find that each of these are solutions. So when you're looking at a graph of a polynomial where it crosses on the x-axis, that's going to be your solutions. So let's take a look at this next one. We're going to graph this guy, and this is our factored form of it, factored form. And what I was saying about that zero product property is we set this equal to 0, and we say, okay, x minus 7 equals 0, x plus 1 equals 0, oops, x minus 1 equals 0, and x plus 3 equals 0. And so if we add 7 to both sides, we would have x equals 7, x equals -1. Add 1 to both sides, x equals 1, or -3, so it would be x equals -3. And sure enough, let's go out and type this over here so that you can see. We have x to the 4th minus 4x to the 3rd minus 22x squared plus 4x plus 21, and sure enough, look at that, it is crossing at -3, -1, 1, and 7, which is exactly what we said on those ones. Did I type that in correctly? Oh yeah, I have 7 on my list. Okay, so let's go back and take a look at my list here. You'll see, sure enough, yeah, I have 7 there. So that is just what it looks like when you're graphing. In order to solve a polynomial and you have a graph of it, all you do is look at your x-intercepts and see where it crosses on your x, and those are your solutions to that polynomial. Let's take a look at one if it does not. So hold on one sec. Okay, so let's take a look at one that I know has an imaginary solution or a non-real solution. So taking a look at this guy, now this is not yet factored, but if we were to factor it, we would end up with x squared plus 4, and then x, I think it was -3, let me just double check, oops, plus 3. So x plus 3, just like this. Okay, so if we were to factor it, it would look like this. And if I use my zero product property, and you'll see that we get into this more in another lesson, but I just kind of want to show you so you see. X squared plus 4 equals 0, x squared equals -4, square root both sides, and we're squaring a negative here, so it would be x equals 2i, because it's a negative, right? Plus minus 2i. And then over here, x plus 3 equals 0, x equals -3. So we know it's definitely crossing at -3, but what does a graph like this guy look like? And if you take a look here, let's get that, you can see that we have it graphed here. And sure enough, it's crossing at -3. That's one of our solutions. But up here, it makes a little bounce, but it does not cross the x-axis. That is our imaginary number. So keeping that in mind when we have non-real solutions that they're not going to cross on our x-axis. Hopefully this helps, and I look forward to explaining all of this to you in our last video in this unit. All right, we'll see you next time.